Hey guys, Beacon here. Imagine you're given an array and your job is to sort the array by swapping pairs of numbers. Except there's a catch. Let's rewind a bit. You have to partially sort the array. You have to sort it so that there's exactly one inversion in the array at the end. What is the minimum number of swaps you need to get the array in this partially ordered state? Well, to solve the problem, we need to know what an inversion is. An inversion is basically a pair of two elements in an array, where the one to the left is larger than the one to the right. Now that we know what an inversion is, what does an array with one inversion look like? Well, you can play around with an array and realize that any sorted array with two consecutive elements swapped will have exactly one inversion. Any other array will either have no inversion, as it is sorted, or too many inversions. So, how do you solve this problem? Well, we can first realize that this is very similar to the classic question of sorting an array by swapping numbers. How you solve this problem is to find cycles. You can create cycles by starting at some element and pointing towards the element that the current element's value should be in. Each cycle will require the length of a cycle minus one swaps to resolve, and you can add these up to get your final answer. This is because in each swap, you will put one element in the correct position, except the last pair in a cycle, which will put two elements in the correct positions. Now, how do we solve this modified problem? Realize that this additional constraint can be either a blessing or a burden. We might need to swap two consecutive elements after it is completely sorted, which adds 1 to the number of swaps in addition to what we need to sort it. Or we could, while we're swapping to sort the array, just not swap some two consecutive elements at the end, which will reduce the number of swaps needed by 1. So now consider the cycles. Remember what I said before, each cycle will require the length of the cycle minus 1 swaps to solve. And why? Because each swap will just put one of the elements in the correct position, except the last one, which will put two elements in the correct position. This means that if a cycle has two consecutive elements, we can just not swap those two until the end and swap every other element, meaning at the end, we're left with just those two elements in the wrong order, which will give us our one inversion, and we can just leave it alone. This proves that if a cycle has two consecutive elements, we can minus 1 from the number of swaps required to sort the array, as we save one swap from not swapping those two consecutive elements at the end. Now we consider the case where no cycles contain two consecutive elements. Well, in this case, we essentially have to swap some two consecutive numbers, and swapping them will just swap two elements of different cycles. And these two different cycles will not change just because you swap them. They still have the exact same elements in the cycles, and all you've done is just moved one element of the cycle to a different position, which won't affect anything. This proves that if no cycle has two consecutive elements, we'll need to add one swap to the number of swaps that we need to sort this array. And with this, we're done. I hope you enjoyed this problem, and stay tuned for more interesting and cool problems.